Today, we're diving into something we all rely on every single second, but probably don't think about too much: the power grid. It's this massive, incredibly complex web that literally powers our modern world. But here's the thing, it's also way more fragile than you might imagine. So let's get into how we protect it. I mean, just try to wrap your head around the scale of this thing. We're talking about thousands upon thousands of miles of wire and millions of individual parts, all having to work together perfectly to keep our lights on. It is an absolute marvel of engineering. But that huge scale? Well, that's also its greatest weakness. And that really is the million-dollar question, isn't it? When you have a fault that's smaller than a crack in a teacup, totally invisible to your eye, and it's 100 feet up in the air on a live, high-voltage line, I mean, where would you even start looking? To figure that out, you first have to understand the threat itself. Because the real danger isn't always the big, obvious stuff, like a downed power line. No, more often, it's something much, much smaller and completely invisible. Okay, so take a look at these things. These are electrical insulators, and they are the absolute backbone of the grid. Their job is to keep the electricity from going where it's not supposed to. But there are millions of them out there, and if just one fails, it can set off a domino effect and trigger a massive outage.
And the kinds of things that make them fail are what's so scary. We're not talking about huge fractures. We're talking about tiny, hairline cracks you'd miss even if you were inches away, or internal defects baked in from the factory. Even just a thin layer of pollution and grime can be enough to start a catastrophic failure.
For decades, utility companies were, for all intents and purposes, just searching in the dark. Trying to find these tiny, ticking time bombs before they went off was a huge challenge, and the tech they had just wasn't up to the task for a long time.
You know, in the beginning, it was literally just guys in a helicopter with a pair of binoculars. Then, in the 80s, we got thermovision, which was cool. It looks for heat. But a lot of these faults just don't get hot enough to see. The 90s brought systems that could measure electric fields, but you had to get dangerously close. The real game changer? Well, that's the technology we have now.
And this chart just lays it out perfectly. It shows the massive leap we've made. We went from only being able to see big, obvious damage, usually after it's too late, to being able to spot the invisible electrical leaks that happen right before a failure. And you can do it safely, from way back, all while the power stays on. The key here is that it's a total shift from being reactive to being predictive.
So how in the world does this new tech actually work? How do you make these electrical ghosts visible to the human eye? Well, the secret is a really cool electrical phenomenon.
It's called a corona discharge. Basically, when high-voltage electricity escapes from a tiny fault point, like a sharp edge or a crack, it actually rips apart the nitrogen molecules in the air around it. This process, called ionization, releases a tiny, faint glow of ultraviolet light. It's literally an electrical leak that you could see, if only your eyes were sensitive to UV light. And that's exactly what a corona camera does. It's got two sensors inside. One captures the world just like our eyes do, in normal visible light. But the other one is an incredibly sensitive UV sensor that is tuned to see only that specific glow from the corona. Then, a processor inside the camera merges those two images together in real time.
And this is the magic trick. On the left, you've got a totally normal-looking insulator. Nothing seems wrong with it at all. But on the right, look at that! The camera shows this bright flaring light of a corona discharge, pinpointing exactly where electricity is leaking out from a hidden fault. The invisible is suddenly right there in front of you.
So, now that engineers have this kind of UV superpower, they can spot a whole library of hidden problems that were impossible to find before. Let's just run through a few quick examples of what they can see now. Okay, so right here, the camera is picking up a super fine hairline crack on a big ceramic insulator. To your eye, this thing would look perfect, but the electricity seeping out of that crack is creating a corona that the camera spots instantly. This allows crews to replace it before it completely shatters. Now, this is a huge one, especially if you're near the coast or in a big industrial area. So, pollution and salt build up on an insulator. When it gets a little damp, that gunk becomes conductive. But little dry spots remain, and electricity starts arcing across them. That's the corona you see here. And that is a major warning sign of a huge flashover event.
The precision here is just nuts. From hundreds of feet away, totally safe, the camera can spot the corona fizzing off a single broken strand of wire in a massive cable. See, that little sharp broken edge creates the perfect point for electricity to leak off into the air.
And check this out, it gets even more sensitive. That glow, that's being caused by bird droppings on the line. Now, that's probably not going to cause a blackout tomorrow, but it represents a constant drain of energy, a slow, steady leak that, when you add it up across the entire grid, costs millions of dollars in wasted electricity.
And it's not just for the big power lines either. Here, the camera is peering deep inside a complex electrical substation. It's found a critical fault on a part of a current transformer. Finding a problem like this early on prevents a catastrophic, and I mean very expensive, explosion of a vital piece of the grid.
So, what's the big takeaway here? What does all this add up to? Well, it's way more than just some cool tech. It's about reliability, it's about safety, and ultimately, it's really about keeping the lights on for all of us.
What this does is put an unbelievable tool in the hands of the engineers and the crews out in the field. They're not just guessing anymore or waiting for things to break. They can go out and surgically target problems before they even start, making sure that the grid that we all depend on stays strong and stable.
And here's the bottom line. This is why it matters. It means fewer catastrophic failures, which means fewer blackouts for you and me. It means the maintenance crews can do their dangerous jobs more safely. It means we stop wasting huge amounts of energy. It all leads to a stronger, more reliable power grid for everybody.
And really, that's the whole point. This incredible technology gives us something like foresight. It lets us see the future. It's about turning grid maintenance from a reactive cleanup job into a proactive, predictive science. We can literally fix tomorrow's problems today.
It just makes you wonder, doesn't it? If we figured out a way to see the invisible world of electricity, what other hidden forces and phenomena are all around us, just waiting for the right tool to reveal them? And what other huge problems could we solve if we could just learn how to see?
We are FMG Tech. Contact us for more information. Visit fmg-tech.ir.